Okay, so mutually exclusive events. So we're talking about the probability of events. Okay, and essentially we're talking about two different events. There's event A and event B, and they can both happen at the same time. Okay, and at some points they may even be the exact same thing. We'll get to that later. But we got to go back to our old rules that this U stands for essentially the word or, and the upside down U stands for and.
Okay.
So what this is saying is the probability of event A or event B. So when they're talking about or, what they're saying is when we refer back to our diagram here, so let's say that this guy is A and this guy is B, or is the idea that you're using anything in B, and actually this will work out great because when you combine the colors, they'll change. Perfect. Okay. So what we're saying here. Okay, I know the look-alike is the nicest, but or means anything inside of A, anything inside of B, but not including this, where they both happen at the same time. So P at A is the probability of event A happening, so anything in here, plus the probability of event B happening, anything in here, subtracting the probability of both A and B happening. So essentially it's subtracting this idea in the Venn diagram. That's the or idea. And then you can do vice versa to figure that out. And then what we've done with probability is the exact same idea on top. All you're doing is dividing by the total number of actual outcomes of something. So let's talk about die. And an easy way to set up die, especially because we're used to using 6 on each side, we'll set it up almost like a multiplication chart. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I think I might have done 7 there. 1, 2, 3. Oh, no, I didn't. Good. Okay. So let's set up a die and go through a question kind of like this. We'll call this guy D1 for die 1. And your options for dice 1 are essentially 1, 2, 3, 4, 5, and 6. And we're going to talk about the sums of die. And then for die 2, you also have the exact same options. What we're going to do is go through this as a chart, summing everything. So essentially 1 plus 1 gives us 2, like a bingo chart, right? 1 plus 2 will give us 3. And we kind of go across it like this.
Yeah.
2, 3, 4, 5, 6. I almost forgot how to count there for a second. All right. And then same thing down here becomes 2, 3, 4, 5, 6, 7. Well, the lucky thing about this chart is diagonally all the numbers are going to be the same.
Yeah.
2 plus 2 will be 4. All right. And then we can put our 5s across here. 6s. 7s is the absolute most common thing when rolling 2 die. And then we have our 8s. Okay. 9s. 10s, 11s, and then finally one option of 12. Okay, so these are all the options in a die when you sum them together. Altogether, we can tell how many outcomes there are by essentially multiplying what you would consider like a length times width in terms of area. So how many options do we have across one way?
6.
And the other way?
6.
So how many outcomes are there with 2 die? 36, all right? So that perfectly makes sense. We know everything here is going to be out of 36 no matter what we do. That is essentially our n at s from the formula above. Okay. Now, they've given us a question, event A occurring. Event A, so we'll call it event A is, what have they told us? A pair. Okay. Event B.
Sum of 6.
Okay, so sum 6. And then event C, a sum of 6 or a pair. Okay. So event C gives us that or option. So we'll say pair or sum 6. I don't want to write over that 36. Okay. So let's actually go through this one step at a time. We'll highlight yellow being our pairs. Well, anything that's a pair is actually quite easy to go through here. 1 and 1 will be a pair, 2 and 2. And if we go on a diagonal with a kind of negative slope here, you'd say, here are all our pairs. So how many pairs do we have?
6.
6, that's right. And out of the total number of outcomes?
36.
Yeah, so we have a 6 in 36 chance of getting a bunch of pairs. Sum of 6, because of the way we set this up, a sum of 6 is extremely easy to find. We essentially just go across it like this. And that one turned green. We have 1, 2, 3, 4, 5. How many?
5 out of 36.
Yeah, 1, 2, 3. Yeah, perfect. So we have 5 out of 36. Okay. So we've already answered part A and B. Now the last one says or. Okay, a pair or a sum of 36. So that one where we've kind of double highlighted, this is the AND option. So in our OR, we actually have to get rid of the AND option.
Okay.
So counting, this becomes simpler, but it's very simple. Or what that means is I'm looking for A, so these options here, or these options here, but I'm not including this one here because that's when both happen. And we don't want when both happens. It's either one or the other. We don't want both events happening. So by counting 1, 2, 3, 4, 5, 6, 7, 8, 9. The answer is going to be 9 out of 36, but let's try to algebraically find how they got this. Okay, so we're going to get 9 out of 36. But if you remember, when we're finding a probability of OR events, so we're going to say A or B, what we look for is the probability of event A plus the probability of event B, subtract the probability, in this case it's of event C, okay, but sorry, not event C, of A and B happening. Okay, that's going to be our event C. In other words, we've called it A or B, but it's really, in our question, we've called it just event C. Well, the probability of A we found to be 36, so 6 out of 36. Probability of B was 5 out of 36. And when they both happen, so and, when did they both happen?
Once.
At that one point. So that's 1 of 36.
Okay.
So we're going to be subtracting 1 of 36. Oh, my numbers don't seem to add up here. That's going to give us 10.
Minus 1 is 9, right? Or 11.
No, I got 11. Let's just double check what we've done here. Sorry. When I was counting, the one reason we don't count that, and what I meant to say is we don't count it twice. So really, if we were going to go through these and just add them together, this would be 1, 2. This event does occur 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, we've double counted this point, and that's what I should have been focusing on. Sorry, I didn't mean to miscount it. Because we've double counted this doesn't actually occur twice. It only occurs once.
Yeah.
So that's why we subtract the idea of both of them happening at the same time, because then we're double counting. So really, we should be looking at 10 in this case, not 9. Sorry.
That's okay.
So because we have 10, algebraically, this makes sense now.
Okay.
We have our 6 plus 5 minus 1. Well, that is going to give us 11 over 36 minus 1 over 36, which is essentially you have a 10 and 36 chance of event C happening. So that's one or the other, okay? And again, the whole idea is we don't want to double count this, because if we were to go through it, we would count with 11, we subtract the double in this. It's always good to catch your own mistakes.